All right, we've got day 25 coming up in about 30 seconds. I hope you all have had a great time going through Advent of Code. I hope you've enjoyed the videos on every day. We've only got 5 stars missing, so I should be able to end this with 45. Here's day 25. It's the last of our ASCII art, and we've got to calculate Snafu numbers. As the expedition finally reaches the extraction point, several large hot air balloons drift down to meet you. Crews start unloading equipment, a fuel heating machine. The fuel heating machine is a new addition to the process. The elves attach a pair of googly eyes to the machine and call it Bob. To heat the fuel, Bob needs to know the total amount of fuel that will be processed ahead of time so it can correctly calibrate heat output and flow rate. This amount is simply the sum. Why would they say simply here? This amount is the sum of the fuel requirements of all the hot air balloons, and those fuel requirements are even listed clearly on the side of each hot air balloon's burner. You assume the elves will have no trouble adding up some numbers, and are about to go back to figuring out which balloon is yours when you get a tap on the shoulder. Apparently, the fuel requirements use numbers written in a format the elves don't recognize. Predictably, they'd like your help deciphering them. You make a list of all the fuel requirements, but you don't recognize the number format either. Copy this. Fortunately, Bob is labeled with a support phone number. We call and ask for help. The Snafu are sort of like normal numbers. You know how starting on the right, normal numbers have a ones place, a tens place, a hundreds place, and so on, where the digit in each place tells you how many of that value you have. It works the same way, except it uses powers of 5 instead of 10. Starting from the right, you have a ones place, a fives place, a 25s place, a 125s place, and so on. You ask why some of the digits look like subtraction or equality instead of digits. The digits are 2, 1, 0, minus, and double minus. Minus is -1 and double minus is -2. So because 10 is 2 5s and no 1s, then Snafu's written 20. Since 8 is 2 5s minus 2 1s, it's written 2 equals. So this isn't just like base 5 or something. You can do it in the other direction too. Say you have the number 2 equals -1. That's 2 in the 6 2 5s place. The 6 2 5s place, really? What is it? 0 5 25 125 625. Okay, I see that you've connected yada yada. The brochure. It's how cold. There's no way the fuel or any fuel would work in those conditions. There are only a few places. The elves pour something into the fuel tanks. Brochure contains a few more examples of decimal numbers and their equivalents. Based on the process, the numbers in the example above can be converted to decimal numbers as follows. So we've got a bunch of tests. 4890. As you input this number, you discover that some buttons you expected are missing. Instead, you're met with buttons labeled whatever. Reversing the process, you determine that for the decimal number 4890, the number you need to supply Bob's console is whatever. The elves are starting to get cold. What number do you supply to the console? So basically, we've got a custom number format. Let's start with taking all of these and making tests out of them. So I think we'll have a struct probably Snafu, and we'll have an impulse Snafu that has a function. Could probably implement from string. So maybe we just make this from string for Snafu. Then when we write our tests, which we'll ignore everything for now, and then write fn parser works, which we've got this input for. I feel like it might be useful to write these as separates. So for all of these, it's going to be assert equal this string. I'll parse Snafu, unwrap, then these will be the answers. Think that'll work. I probably messed something up here, or I'll probably change something as well. Cargo watch test, missing the error type for from string. There we go. The error can be a string. It doesn't really matter. What should a Snafu actually be? I guess it should have a decimal representation of the number inside of it, which will be what, like an I64. We need these to be derived debug and partial equality, which the decimal should take care of. Expected Snafu found integer. Oh, right, because I have to wrap all these now. So if we do it this way, it'll be like this. It'll be like decimal. So it'll be more like that. We could do like the Snafu as whatever. So maybe we'll do more trade implementations later and clean up this testing stuff. But for now, I'm just going to test them like this in the wrapped form. So we do need to add test to the top of this so that it will run the test. And then parser works is failing in this case because we've got it to do. So we've got a string slice here that we need to turn into a Snafu. These are basically bits, right? Oh, we've got more examples here too, which is probably even better. We should probably also bring these in as tests, but I'll hold off for a second. So I actually think that this might be a great opportunity to investigate other testing frameworks. So there's a concept called table-based testing, and I can't remember what crate that I used, in what day of advent of code, in what year I've done this before. So I'm going to go to lib.rs and I'm going to search for table test to see what people are using these days for that kind of approach. You can see there's a number of different results. The most likely seems to be this one, because the first one is outputting tables with content wrapping. This is a Rust test framework that has also seen recent releases. I can't find anything like cases or tests. So instead of trying to dig up what I've used in the past, I'm going to start using rs_test. So rs_test has a dev dependency and is meant really to help write fixture and table-based tests. Table-based tests are what we are looking for, sort of data-driven tests. So we're looking for something like this specifically. So I'll just copy this for a moment. And really what I want is I'm after this multiple test output. So you'll remember that if we compile a bunch of asserts into a single test in Rust, we'll only get one output. In this case, as I'm writing all of these, I want to see all of them failing. Now, it doesn't say anything about being a custom test runner, which is something else that we can go over. So I'm going to assume that by doing cargo add dev rs test, I guess the other one that would be interesting is cargo next test, but I don't think it's a table-based testing framework. I think this is a test runner only. Cargo next test, of course, is very cool, but I don't think we need it. And I don't think it helps us in this situation. But depending on how many tests we have and how noisy they are, maybe we'll look into using this for filtering. So let's do this right here. In this case, this is going to try to run some function called Fibonacci. We are using the rs_test macro instead of the test macro. And then we have to write case with the input and the output. So in this case, we're using this to define input as the input and expected as the output. And then this is going to be for us input.parse snafu.decimal. We can save that. Input here is a U32, so we're going to make this a string slice, and expected is going to be an I64. We'll unwrap here, because if it fails, we need it to fail. And then we'll go back and grab our input. It's really annoying that they took all of these and flipped them into two different columns. So I'm going to drop this in here. Okay, so I hit Shift Control A, and that gave me everything to the left. So I'm going to put these in as strings. Of course, we need to use the case macro, where these are the beginnings, and then we do commas, and these are the endings. And hopefully that will work. So all of these Snafu numbers turn into these decimal numbers. We'll get rid of these extra cases, and then I'll get rid of this huge batch of tests. And the other thing I want to do is take all of these and do the same thing. So I want all of these tests, basically. We'll get multi-cursor going, case with the open. These are going to close like that. And then all of these can go here. Okay, so this is every number and every decimal number in a huge table that we then parse and check against the decimal. So if we run cargo test now, it should all fail. In this case, it says Fibonacci test case, whatever, and they're all panicking. So we want to rename this, of course, to Snafu parse test. So we can do that, and we can see that we have 28 failing, 2 ignored, and they're all panicking, but we see the output for all of them, or any of them that we want to see anyway. So we should be able to now write our parser. So we've got 2, 1, 0, minus, and double minus. Minus is worth -1, and double minus is worth -2. So if we look at these, this is double minus, and this is single minus. So I feel like we could definitely write a non-parser for these numbers. 2, 1, 0, minus, and double minus. So let's start with a snafu digit. And this can only be -2 to 2. So we could put this in the smallest number we could possibly fit, which is an I8. So we can do many1, alt is probably what we want. And then inside of alt, we'll do car2. These are all individual characters, right? So car2, car1, car0, car negative, car equals. Is that right? 2, 1, 0, negative, and double negative. So each of these will get mapped over. And then 2, 1, 0, -1, -2. We pass the input in here. and this needs to be a vec of I8s, and that should get us our digits at least. Although I did say this was for a single digit. Let's go digits. I don't think we need a single parser. So Snafu then probably needs to start with, I'll probably just write a second function here because I can't think of the exact right way to abstract this. So I'm just going to start writing code and then I'll re-abstract it later. So Snafu is the input into an I64. So let underscore Snafu or digits, right, equals Snafu digits input, and then digits dot iter dot reverse dot zip 0 dot 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 step by 5 dot enumerate. No, enumerate the whole thing. So all of this dot enumerate, right? Fold initial value 0, function accumulator, and then item, whatever item's going to be. So can I get a format here? Let's do a to do here, and let's get this commented out so that cargo format runs. So what we're doing here is we're running an iterator over each of the digits. We're doing it in reverse order because we need to start from the right hand side. If I remember correctly, I'm going to check that in a second. And then we're zipping that iterator with a sequence of fives stepped by 5. So 0, 5, etc. I guess we don't really need to do that. If we just enumerate, then we know what position we're in. So at this point, we get usize and I8. So index with the number, at which point contribution to the number is the item dot pow index, right? No. The item times 5 to the index. Does that sound right? Because the first one represents 0. So 5 to the, 0 is 0. 5 to the 1 is 5. 5 to the 2 is 25. So it is the index. And then I think it's multiplication. This is all going to be a usize. So we'll have to do this, or not all going to be a usize, but the index is a usize. We'll do 5 I64.pow, and then this as I64, I74, that doesn't exist. I64, and then I think that's right. The item needs to be dereferenced, the index. What does the index need to be? Expected U32 found usize. Expected U32 there? Does POW only accept U32? So the contribution to the number is this calculation. So we do at ACC plus equals contribution. We return ACC. We actually don't need this to be mutable because we can just return this instead. So the decimal equals this, and we return okay, input Snafu decimal, and this is input, and Snafu decimal is a problem because this is probably like an option type because of the fold or something. Expected I64 found struct Snafu. This is going to be a Snafu return, not a decimal. Okay, so we've got the parser that we want to use. We can do let input, which we don't care about, Snafu equals Snafu s. And now we have a choice. Do we want to do strings for the error? If we do want to do strings for the error, this is fine. Then we just take the error and then we can just like do something silly like debug out the error for our purposes and then return unparsable. And then we do the question mark and that handles it for us. And then we get Snafu. So we return, actually, we can just return this. No, we can't, because we're going to return, okay, Snafu, not anything with the input. So theoretically, that should work. It works for all of our cases. So we just saw all of our test cases pass, which is really nice. So all of these are being parsed correctly, at least. So we've got the decimal numbers now, and we need to convert it back as well. So let's start by implementing a little bit of what we're supposed to be doing. So I think this is the list of numbers, right? So let's do, I guess we have the test file, right? Here's our test file. For process part 1, we can start off with input.split. In this case, I'm going to split on new lines, .map, string, s.parse, Snafu. All of these need to succeed, so I could just unwrap here. Then we get sum as an I64, right? So this is the code we want to write. This will not work for us at the moment. Sum specifically is going to be the issue. So sum Snafu is not implemented for I64. So impl sum Snafu for I64, implement missing members. For sum, we get an iterator of Snafus, and we have to return an I64. So that's what this is saying. We are implementing sum with a type argument of Snafu for a result value of I64. So this function sum has a generic argument I that's an iterator with items of type Snafu, so that's R type, and we get the iterator here as iter, and then we have to return the I64. So this is pretty easy for us. iter.map snafu snafu.decimal.sum, and that's how it works. So we get the let's let sum equals this and debug sum. And of course, all of our tests are passing because we're not even running the part 1 tests. So we get 4890 for that sum, which I believe is the right answer. 4890 is the sum. This is the output that we need to put out. So we've implemented this for I64, right? But it would also be nice to implement it for Snafu, which is really easy for us because we created Snafu, which means all we have to do is wrap it in Snafu at the end. And now we've implemented sum for Snafu, which means that we can sum this into a Snafu. And now we get Snafu decimal 4890. So we split this, we parse it into Snafus, and we sum into Snafu. And we've hidden the implementation details of how we do that up here. So for example, we don't need this I64 anymore because we're now using this implementation. And all it does is make sure it pulls out the decimals and sums them, returning us another Snafu. So as a user of these things, we don't need to care about how the data is stored. All we need to say is, hey, we've got a bunch of Snafus. We would like the sum of those Snafus. Can you give that to me? Now we could go deeper here. There are other traits that we could implement for Snafu, such as add, which we don't have currently. We might need those for part 2. We don't need them currently. So all I'm going to implement is sum instead of like add and subtract and things like that. So the sum is correct and we need to turn it back into a Snafu number. So we'll impl Snafu and we'll do as or to, because we're doing a conversion to Snafu string, which will return a string and takes a reference to self. And then we have to figure out in here what to do. I think this is somewhat like factorization. So I think the problem here for me comes in the form of how do we do the negative numbers? I'm sure there's a conversion here that would have made this really easy because we're kind of in base 5, but not quite. Yeah, the issue for me is I don't know how to deal with the negative numbers for sure. I feel like we could do, for example, like divisions by 5 and stuff like that, but we still have to get to a value that can go positive and negative. I guess we can take all of these and redo the next test, right? It said something about being able to reuse fixtures or being able to reuse cases, right? I didn't mean to click that. So we need a second crate for that. RS test reuse, and it says basically reuse the input here. That seems easy enough. Cargo add dev rs test reuse. We look at cargo toml. We've got 2 dev dependencies on rs test and rs test reuse. So we can do, well, this is the import. So let's pull the import here next to the rs test. And then we've got this apply. And we're going to apply this. And this is going to be expected and input. Input is an I64. Expected is a string slice. This looks like there's an issue, probably because of the assert. Cannot find, what is apply? Oh, we have to put template on the other one too. So we have to put the template macro here, I think anyway. Template rs test. Could not find rs test for use in the crate root. In the crate root? Why does it need to be in the crate root? You're telling me it needs to be up here? Interesting. This looks like a macro scoping issue. So I'm going to go look at the docs for this. Okay, it's possible that this just isn't meant to work. Could not find rs test for use right here in the crate root in the procedural macro expansion for mod tests. I feel like it doesn't need to be in the crate root. No external crate rs test for use. Did I add the wrong thing? Nope, rs test for use. Do I need to restart this? Okay, so now we're back into the issue that we just saw with the template, right? We can't use it here because why would we do that? We have rs test for use defined as a development dependency. So putting it in the crate root would be weird. I feel like apply conflicts with something. This error originates in the macro snafu parse test, which comes from the expansion of the attribute macro apply. Oh, I guess in nightly builds, run backtrace for more info. It would be really weird if that fixed it. And I think it did. I don't know why the macro requires that. It feels weird, but the way that we can get around it is by using the config macro. So if we config for only in the test environment to use rs test for use in the crate root, which in this case is lib.rs, then this will only get compiled in when we're testing, and it puts it in the crate root, which is what the test framework wanted, I guess. I don't know why it wanted that. Okay, so we have the input in the string, right? So if we do expected here and snafu decimal input dot to, what did we call this? I forget what we called this. To snafu string? I thought that's what we called it. Yeah, that is what we called it. Then we're good other than the plethora of warnings. So we've reused the Snafu parse test cases. We flipped them. So the expected is now the string and the input is the I64. And we've done our toString. So if we go back up to toSnafu string, I still don't know how to do this. We've got 4 options for each bit. The numbers go up pretty high, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, whatever 5 to the 8 is. So it has a 390,625 place. So what happens if I divide this by 5? We end up with 62,000 or 62,831,853. Does that work in general? If that's how many 5s we need, right? The thing that's tripping me up is still the positive negative thing. Like if it was just positive, we could just keep dividing. If it's negative, then what does it look like if we do this as base 5? So let's do toSnafu string. I feel like we might want an unfold here. This is a crate. That's not really what I wanted. Unfold exists in iter tools. I thought we had one in regular Rust. Standard iter unfold. So we do have unfold. So let's do just iter tools unfold, right? Initial state 4890. Then we've got some function. This will be num. Nummod 5 is what I want to keep doing. Maybe this just works. I don't want to name it car. Let's name it C equals nummod 5, right? And I'll get rid of all this other stuff. Is percent actually what we want? This is expected option. Does unfold expect options? Yes, it does. Otherwise, we return none. When do we return none? Who knows? Maybe if num is 0? Num is an I32, so I have to do the reference here. Num mod 5. Can we num mod 5 here? Do I need to do this? Okay. Value of num mod 5 gives us one of the indexes. 0 is 0. 1 is, so these all these return values have to be this. So even 0 has to be num 5, right? We collect this into a string. 2 equals negative 1, 0. 2 equals negative 1 equals 0. 2 equals negative 1 equals 0. That's reversed. We can't do .rev because it's a double-ended iterator, or it's not a double-ended iterator. So if we collect this into a string, result should be an iter. Method iter not found in string? Cars. I'm losing it at this point. Collect that into a string. So it's 2 equals negative 1 equals 0. 2 equals negative 1 equals 0. If num gets to 0, then we've succeeded, right? So we're basically modding this to get the current value. My grasp on this is tenuous, so bear with me. The largest index value for this number, if we are in base 5, can be found by modding it by 5. Okay, so I'm fairly confident this is the right answer. The problem is that I'm not 100% why it's the right answer, so debugging is rough. Oh, we're not returning this. We need to return this. Part 1 works as failing. Okay, so there's some math here where if you do mod 5 on this, even though it's this weird negative number thing, there's some association where if we mod it by 5, which I feel like that's what I would do if I was given a number in base, or not a number in base 5, but a number and told to output it to base 5, right? Then I would do something like num mod 5. That somehow gives us the index we need. So if we num mod 5, right, then we should get, okay, forcing this to fail to understand it a little bit better. Num mod 5 is different for all of these. I want this to be our number. I forgot the number. What number were we working with? So the top of the test debug output, isn't it? Where is it? Snafu something or other. 4890. 4890. So if we take a look at this, this is the wrong answer for all of them. So we should get 4890. We get 031432. 03. Okay, even staring at this, I don't understand why this works. So if we mod 5 on num, this has something to do with base 5. If we mod 5 on num for 4890, this is the base 5 representation of it, right? So if we num mod 5 and we have 0 as our first number, this should be 0, right? So if we num mod 5 or num divide 5, then we do the next one as 3. So the 0, 3. So we're good so far. But then we get 1, 4, 3, 2, which doesn't match up with base 5s. Do we have the wrong base 5 number? 124030. To convert decimal number 4890 to base 5, divide by 5, keeping notice of the quotient and the remainder. Continue dividing the quotient by 5 until you get 0. Then write out the remainders in reverse order, 030421. But that's not what we get. 031432. Why do we not get that? 030421. That's what we should get, right? Let's just get everything debugged out here. So debug num 4890, mod 5 is 0, is 978, mod 5 is 3. In our case is 196. Oh, in our case is 196 because I messed it up down here. But the mess up down here is the thing that we need to calculate the like alternate base. I have no idea why the order of these is the way it is. But we do, if we continue like that, we do get the equivalent of base 5. So we're just trying to do it into like this weird negative base thing. So like quotient or like the remainder of mod 5, right? That's our base 5 if we just reverse those numbers. If we swap them out and fiddle with the math, so we're doing -2 instead of 3 and -1 instead of 4, that's how we get this other base. But I really couldn't tell you why adding these numbers like that works. That's a tough one for me. It feels pretty arbitrary. So anyway, let's continue because this seems to be the right thing. So self.decimal, result.cars. If you're aware of why this -2 is here and -1 is here for this, please add the comment because I don't understand. I tried a bunch of stuff, a bunch of base 5e kind of stuff. I really didn't know that this mod was going to give us the right answer. I had to like figure that out. But our to Snafu string is an unfold. So basically, if we're going to do a repeated operation on a starting value to produce a set of values, that's an unfold. So a fold reduces a bunch of values into one, and an unfold is the opposite direction. It expands one value into a bunch of values. So if we take the decimal as the starting for this unfold, then we get a function where if we return a value, it gets produced by this iterator. Otherwise, num is mutable, so we can just keep modifying it for every iteration. So we start off with decimal. We have to have an end case. So if num is 0, we return none. The iterator stops. Otherwise, we match on the mod of 5, and we set the number, which results in an iterator that we can collect. So we can collect that into a string. It's not a double-ended iterator, which means that we can't iterate from both sides because we're just producing values. It's not like we're iterating over a vec that has two sides. So we collect that into a string and then we can reverse it to get the end result because we're producing them basically in opposite order from biggest to smallest. Or rather, I said that wrong. We're producing them from smallest to biggest. So part 1 here, then, we just need to sum.to Snafu string as our return value. And that'll give us part 1 successfully with all of our other table tests. So if we cargo run, I didn't put the value in here. Puzzle input. Hopefully this works because if it doesn't, I'm going to have a hell of a time debugging this. Input this, run part 1. This is apparently what we need. So if we put that in, we get a gold star. So we continue to part 2. The hot air balloons quickly carry you to the North Pole. As soon as you land, some of the expedition is escorted to the reindeer stables. It will take 50 stars to fill the blender. The expedition elves turn their attention to you and you begin emptying the fruit from your pack onto the table. As you do, a young elf approaches the table and holds up a singular star fruit he found. The head smoothie chef places it in the blender, only 49 stars to go. You don't have enough stars to fill the blender though, you need 5 more. Oh, so this is just like do all of the rest of them. Okay, well, I have 5 more to go. So I'm ending at 44 right now. So I missed day 16. Hopefully going to get back to that. We've got part 2 for a couple days and then day 25 that didn't happen. So I'll commit this code. The Snafu stuff is interesting. I vaguely remember it being a similar problem last year. I'm probably going to cut out me stumbling over all of the mod math because now that I know, it's significantly easier. It took me a while to figure out that in base 5, the way that you generate a base 5 number, so 124030 for the number that we were looking at, which was like 49,080 or something, that you just do mod 5 over and over. So other than that, which I stumbled over quite a bit, I'm pretty happy with the parser. I'm pretty happy with what we've done here. I'm pretty happy with the structure that we have. We could implement like add and subtract and things like that, but we didn't need to do that this year. We've got our nom parser, which we throw into 2 strings so we can use parse. We've got some implementation, and we've got table tests, which are really fun. So I hope you enjoyed Advent of Code. I hope you enjoyed these videos. I will try to get you the rest of the videos at some point. If you enjoyed the videos, let me know with a comment because it's been a lot of videos. And yeah, I'd appreciate knowing that you got through it. So I hope you have a great rest of your day. I think that this is going to be pretty close to my last video for December. So I will probably see you in the new year. I think I'll have this video and then one more this year. So yeah, have a great rest of your year and I'll see you soon.